Good morning, everybody. Welcome back. Today is Monday, October the 22nd. For those watching this at home, this is a lesson on inequalities. A lot of you actually seen this inequalities, and again, you may or may not have this handout just yet because from our class purposes, and so we designed it. You actually were taught inequalities in grade 9, depending where you came from. If you had me for grade 9, I definitely taught this, but 2 years ago, I was not here. I was up in my year up. And so we're going to actually explore this. Okay? So if you can take out your handout really quickly. A lot of you actually seen this symbol before. 8 is greater than 5. And on a number line, clearly on towards the right, if the 0 is here, 8 is clearly a larger number than 5. This is actually a true statement, right? How do you understand this? Okay. So what we're going to do first of all is look at the properties of inequalities. And again, you've actually seen an inequality already because you did your first test with me. And it was on stating restrictions, right? And then this restriction is an inequality. Jay, you okay?
I'm missing a passage.
You missed that second handout?
Yeah, Sam, I don't have it.
Was that beside you?
No.
So you can take this one. Anyone else? Ivan, you didn't get one? Beside you?
I have one.
You don't have one?
No.
Thought I handed them out before. Yeah. You're kind of smart. I hope I'm here. Anyone else? There you go. Anyone else? So, the inequality we're looking at, well, this, a lot of you know this sign is equal sign. This is not equal. Greater than or greater than equal to, less than or less than equal to, right? Hopefully everyone knows that. But a lot of you still kind of didn't learn how to solve linear inequalities. And so this is like a little proof here that we're going to follow this chart here. And the first thing that it has done is actually says add 2 to both sides. And as we add 2 to both sides, we're basically trying to confirm whether or not this is true. So when we add 2 to both sides, we get 10 and 7. And notice that is still a true statement. 10 is still larger than 7, everyone agree? And again, it's written on your handout. It is true. How about the second one? When you subtract 2 to both sides, we subtract 2 to both sides, we get 6 and 3. So hopefully everyone's doing it with me. We're just filling this out. And that's still true, right? So this is still true. We'll do the capital T here, capital T. So far, so good? So notice with adding, subtracting, some of you are saying these inequalities are like straight lines, right? They're like linear equations we can solve. How about with multiplication? If we multiply both sides by 3, we get 24 and 15. And again, notice this is true. Some of you are saying, Mr. Chen, this seems silly. And again, if I was off screen, I do apologize. I think we can see that there over there. Thank you. If we divide both sides by 2, notice what we get? We get 4 and 2.5. So a lot of you already realize that this is already seems a little silly to do, this exploration of proving. However, a lot of you know what I'm going to do next. And notice, we're going to multiply by -3 and divide by -2 to the statement that we were looking at. 8 is greater than 5, but when we multiply by -3, notice what we get? We get -24 and -15. Now, some students, when they look at this, I kid you not, they'll still say, Mr. Chen, what are you talking about? This is a bigger number than this. What are you talking about? In terms of its magnitude, yes, that is true. However, a lot of you realize in order to make this true, we have to flip that inequality. Notice, unlike our first 4 examples, and just pause for a second if you need to look at it, I had to make this true now by flipping it. Right? So of course, if we put it like this is false. Right? One more time, in order to make it true, it has to be that. Maybe it happens with division. Let's try that with division. Notice what we got? 8 divided by -2. We get -4 and -2.5. And I think again, a lot of you realize this is now true. In short, some of you actually notice that the handout already tells you if both sides of the inequality are multiplied or divided by a negative number, the inequality sign must be reversed. And so this is your first glimpse of solving linear inequalities. It seems kind of weird because this is actually a big part of domain and range. That's why we have to kind of do this first before we can keep on going. However, notice we have a number line, and for question A, B, and C, we're going to do this. For some of you want to know actually what's happening. So there's two number lines there, and we're going to take a look at A, B, C only. D, E, and F, I think a lot of you will try to do it yourself. And all you're really doing is graphing on a number line. Now some of you say, Mr. Chen, I don't know how to graph on a number line. I know how to graph on a Cartesian plane, X's and Y's. This should be pretty easy. So for question A, I'll use yellow if that's okay. X is equal to 3, and it's just to make sure you know what you're going to do. 3 is over here. Notice it's towards the right. And what am I going to show? Well, again, I apologize because I'm teaching. I'm going to put a filled in circle above. If you take a look actually at the answers of some of the questions, notice that the answers are actually lying on the number line. And you can do that, but because I'm teaching it, I'm just going to introduce it. Now notice that's how we graph it. And a lot of you realize with an equal sign, it's a filled in circle. So notice what I'm doing for the greater than or equal to sign or less than or equal to sign. Equals means to include or fill in. And that's what you're going to draw, a dot. So some are saying, this seems silly. But that's what that means. Basically putting a filled in dot where you see it. How about for question B? Notice, for question B, it looks exactly like what you did on your test. It's like a restriction. In English, that means x cannot equal to -2. Now some of you are going to get a little confused right here. And again, it's easier on your handout. You just look. It still looks like an x. A backwards 3 and then the letter I. And some students actually don't know what this means. This is actually the Greek letter epsilon. And in mathematics, it actually represents that x is an element of I. I'll explain what I is in a moment. Now some students still don't like it when I say the elements of, because, let's be honest, we don't really talk in those mathematical terms. So I tend to tell you what this means in colloquial terms. It means x belongs to. So it's a shorthand way of expressing what it represents. So in this case, x belongs to, and I think some of you actually know what I stands for. In this case, I stands for integers. So notice I'm showing a number line from 0 to 3, and I want to show x is not equal to -2. Now conceptually, a lot of you already know what this means. It can be any number but -2. It can be -3, -4, -5, it can be -1, it can be 0. I think a lot of you understand. I'm actually listing integers. Integers. Now to show this, and we'll use red chalk, this is a little silly. Watch what I'm going to do. I'm going to do below if that's okay. So if it was -3 or -1, I put a filled in circle there, filled in circle here. Please don't copy this down just yet. Filled in circle there, filled in circle there, at 1, filled in circle there, 2, filled in circle there, filled in circle 3. Notice I'm leaving, this is a little tedious, Mr. Chen. A lot of you realize that number line goes on forever. So instead of doing that, instead of listing all the other possible integers, in the mathematics, it's a little easier to say what it's not equal to. What is it not equal to? It's not equal to -2. So watch, I'm going to show you the symbol that you're going to draw on a number line. It's going to be a open circle, or not filled in circle. A lot of you realize this means not included. So for not equals, notice what I'm showing you. You're putting an open circle. How about the greater than sign or less than sign? It'll make sense when we do it, but you're also going to put open circles as well. So this is just a communication thing to show. I know it seems weird. Some students, again, find it easier if I draw it like that, but because for teaching purposes, I just don't want to mess you up. So that's for red for not equal to 2. That really says it can be any number but -2. And for integers. Now for part C, notice you have your first real inequality. X is less than or equal to 4. And I think some of you are understanding. Again, it's easier to look at your handout. It says x belongs to n. What does n stand for? It doesn't stand for Nescafe. It stands for natural numbers. We're always talking numbering system. Numbering systems is actually super critical abstract concept that we learn in grade 12 math, or if you want to pursue it. But for us right now, natural numbers are as follows. Now I'm going to use blue chalk to hopefully illustrate this. Notice what it means. X is less than or equal to 4, but the natural numbers. So some of you might not have remembered what a natural number is. A natural number are all the numbers and including 0. So it's basically accounting from 0. So notice where 4 is. 4 is over there. And I do apologize. Maybe I should move this over. So I'm just going to move this over so that my audience can see it a bit better. And I'll just recopy the question in blue. X is less than or equal to 4, where X belongs to natural numbers. Again, I'm just copying that question. So watch what you're going to do. Well, normally, I include 4, I include 3, I include 2, I include 1, and I include 0. And that's where we stop. Clearly what this says is, what numbers are less than or equal to 4? 4, 3, 2, 1, and 0. Here's a good argument though, if you are a math nerd, let's just say. Some students would argue with me, Mr. Chen, we do not include 0 for natural numbers. Just to share with you, I've seen kind of both with whole numbers systems and natural systems, so I can't win. In some sense, you would not hurt my feeling if you did not fill in the 0. And in fact, I'm really not trying to show you the natural numbers or integer values right now. Really what I'm trying to show you is this funny looking word. And some teachers actually teach it like this. Anyone actually want to take a guess from the class? What do you think the R stands for?
Real numbers?
It stands for real numbers, correct? So this means real numbers. So let's try to do question D as a class. Question D is this one. X is greater than -4, where X belongs to real numbers. What would you draw? Now again, you have a new number line. Any volunteer from the class? What should we draw? Simone again.
Like an empty circle, -4.
In which direction should we go? Notice I'm already leading.
Right.
Towards the right. And that's our answer. Some students say, well, how can you put dots? The real number line, that's what this is, includes all the possible numbers. In fact, the numbers from -4 to 0, there is an infinite number of numbers. -3.99999, -3.99998, I think a lot of you understand. We're not going to be putting all these dots. So the way that we communicate to the reader, we don't include -4. It's just a good way to kind of start it though. -4 is not larger than -4, but we just don't include it. This is also your first glance of this idea called approximation, approximating to get a value. And that's what we're going to do in grade 12. Before we continue, any questions? So question 2, sorry, practice part 2, turn the page over, ladies and gentlemen. It says solve each inequality, and these are pretty easy. Just for our class here, it says express your answer in interval notation. Just cross out that word interval notation. We're not going to teach that in grade 11 this year. In the enriched class, we tend to do it. We don't really do it. And graph the solution on the number line. Now, I'm just going to jump to a harder question, question H. And we're going to do this question in a moment for everybody. And again, under test on Friday, it's probably just one question. Very, very similar. So if you can follow this, I think you're going to be set. Question H is as follows. -4x plus 24 is greater than or equal to 0. So this one's clearly much more challenging than our definition questions of inequalities and what I showed over there, right? So I'm going to do this again. Filled in the circle, not filled in, not filled in, not filled in, filled in here, filled in here. It doesn't really have to be in this pattern, right? But some students definitely know. So notice for this question, you're going to solve this inequality. And again, I know it's weird because you're so used to solving equations. Notice you don't really care what this is, so we have to isolate for x. So there's a couple ways to do this question. I'm going to show you the way that most students are going to do it. They're going to subtract 24 to both sides. And notice, if we subtract 24 to both sides, there's no problem, right? One more time, looking back on the first page. If both sides of an inequality are multiplied or divided by a negative number, the inequality sign must be reversed. All we did was subtraction, not multiplication or division. Everyone agree? However, this side, and again, notice this is how you're supposed to be taught in grade 9. We have a monomial and a monomial. That's the whole goal. We're trying to get x all by itself. I wish we could stop here. But a lot of you realize I'm going to show my work. we'll divide -4 to both sides. And many of you can do this. However, the new thing I'm trying to show you, any volunteer who wants to tell me, since we divided both sides by -4, what should we do to the inequality? Omar?
Flip it.
Flip it. So instead of greater than or equal to, it's now going to be less than or equal to. And notice, what you're gonna draw for me, really easy. X6, it doesn't have to be perfect, it's just a sketch. It's just to visualize what this means. A lot of you realize answers now with inequalities, it's a, and I shouldn't use it, it's like a range or a boundary of answers, or interval. I hate using those words because unfortunately in math, they actually mean something. I don't mean to say range, but a lot of you understand it. If you use a filled in circle at 6, it includes 6. And again, if I were to ask you what numbers of x would make this true, you would say 5.99999, 5.99998. You'd be here forever. You'd be getting nice and old and gray and say, like, Mr. Chen, this is stupid. Just say x is less than or equal to 6. Okay, we'll show it. And that's direction. Notice with a number line, it's only, no offense, one direction. You got that one thing. No, none of you, forget it. Any questions about this? Any questions? Some students would argue with me, though. I don't mean to mislead you. Some students say, Mr. Chen, I can do this question a different way. They don't have to worry about this division by -4. And I say, okay, so we're going to do this question again. And some students would argue with me, Mr. Chen, watch what I'm going to do. Instead of subtracting 24, because I was taught in grade 9, whatever you do to one side, you must do to the other side. And that's true. I can add 4x to both sides. Okay. And then divide by 4. Okay, no problem there. So why can't I just write this? Mathematically, this is correct. However, in the inequalities, we tend to have a particular style how to say it. We always say the unknown. What's the unknown? 6 is not the unknown. X is. So if you do it this way, notice what you have to still do. X. Going this direction, from right to left. This is less than or equal to 6. Which, hey, it should be the same answer. So even though this answer looks good, this is the proper way. This is the way. Let's pause the video, answer some questions in class.